So up until now, we've been talking about calculating the mechanical advantage of individual simple machines. So now I want to present a new idea of combining multiple simple machines. And when we combine simple machines, we call that a compound machine. So let's go ahead and define that term for ourselves, a compound machine. And all a compound machine is two or more simple machines working together. So two or more simple machines working together to perform a task. Together to perform a task. And let's actually bring this out just a little bit more to the left here, to perform a task. And if you look at the example here to the left, you can see exactly that happening. And so we have three simple machines, and we can even divide this for ourselves into three simple machines. And so we've got one movable pulley here, a second movable pulley here, and a third movable pulley here. And this third movable pulley is being lifted up. And so we can even draw ourselves some person lifting up this movable pulley with some effort force. And so this person is pulling up on this movable pulley, which pulls up on the next movable pulley, which pulls up on the next movable pulley to lift up this 80-pound weight. And so we have three simple machines or three movable pulleys working together to lift up an 80-pound weight. And so let's even label each simple machine. We'll call this one machine 1. And the second movable pulley we'll call machine 2. And the third one we'll call machine 3. And as we said, they're all movable pulleys, and as we learned in our pulley lessons, the IMA of any movable pulley is just 2. And so we can even say the IMA of machine 1 is 2, and then we can go further. We could say the IMA of machine 2, or our second movable pulley, is also 2. And then we could say the IMA of machine 3 is also 2. And if you need a refresher on how to calculate the IMA of a pulley, you can always go back to our mechanical advantage of a pulley videos. And so the IMA is 2, but we can actually find the AMA of each pulley as well. So we can say the AMA of pulley 1 is going to equal our force resistance divided by our force effort. And in this case, we have multiple force resistances and multiple force efforts. And so I'm going to say the actual mechanical advantage of machine 1 is force resistance 1 divided by our force effort 1. Just to differentiate here, and we can easily figure out what these two numbers are for machine 1. If we look, we can see we're pulling up with 10 pounds of force to lift up this 20 pounds of force. And so this 20 pounds of force would clearly be our force resistance for machine 1. And this 10 pounds would be our force effort for machine 1. And so we can just plug in these numbers. We say 20 pounds divided by 10 pounds. And we see that pounds cancels out, and we're left with an AMA of just 2. And since we got the same mechanical advantage, we know this checks out, and we can assume that we're dealing with an ideal effort force. So we can just say assume effort force ideal. And since we're dealing with an ideal effort force, I can assume that the AMA of each of these machines is also 2. So let's go ahead and figure that out. We could say the AMA of machine 2 is equal to the force resistance of machine 2 divided by the force effort of machine 2. But if you notice, the force resistance of machine 1 is equal to the force effort of machine 2. And that might be a little bit confusing at first, but if you look, we can see this 20 pounds is pulling down on this first machine, whereas this effort force is pulling up on this second movable pulley, which is also being pulled down by this 40 pounds, so we can call that our force resistance for machine 2. But that's also pulling up on our third machine, so we can call that our force effort for machine 3, which is of course countering this 80 pounds pulling down, so we can call that the force resistance for machine 3. And so that actually makes it really easy to plug in our numbers for our AMA for machine 2 and machine 3. We can say that our AMA for machine 2 is equal to our force resistance for machine 2, which is just 40 pounds, divided by the effort force for machine 2, which is just 20 pounds. And again, pounds cancels out, and we're left with an AMA of just 2. And then for our AMA for machine 3, we can do the exact same thing. We can say that it's equal to our force resistance for machine 3, which is 80 pounds, and divide that by our force effort for machine 3, which is 40 pounds. And again, pounds cancels out, and we're left with an AMA of 2. And since we're assuming an ideal effort force, it makes sense that we would get the exact same AMA as our IMA for each machine. But hopefully this is nothing new. We've already learned how to calculate the mechanical advantage of each simple machine. The question is how do we calculate the mechanical advantage of a compound machine? And there's a few ways to do it. And so let's start with looking at this compound machine as a whole. We can see that this entire machine is lifting up 80 pounds. And so this 80 pounds isn't just the force resistance for machine 3, it's also the total force resistance, which is being lifted up by the total effort force of this person up here. And so this 10 pounds isn't just the effort force for machine 1, it is also the total effort force. And so we can say the formula for the AMA total is the total force resistance divided by the total force effort, which is just 80 pounds divided by 10 pounds. And of course, pounds cancels out, and we're left with 80 divided by 10 is just a total mechanical advantage of 8. And so that's one way to calculate the total mechanical advantage. But there are other ways. For example, we could take each individual mechanical advantage of the machines and multiply them together. So I can say the mechanical advantage of machine 1 multiplied by the mechanical advantage of machine 2 multiplied by the mechanical advantage of machine 3. And if there were more, we could do it more. And if there were less, we would just do however many there were. But we multiply them together. And we know the mechanical advantage of each individual machine. They're just movable pulleys. So we can just say 2 times 2 times 2 equals, well, 2 times 2 is 4, times 2 is 8. And so we get the same mechanical advantage. And so both formulas check out. But then there's one more way to find the mechanical advantage total. We could use our IMA. So we could say the IMA total is equal to the distance effort total divided by the distance resistance total. And since we know the total mechanical advantage is 8, assuming an ideal effort force, let me present a question to you. If we pull on this compound machine with 24 feet of rope, how far would this 80-pound weight lift? So go ahead and pause this video and see if you can figure that out. And so the question's asking, how far does the 80-pound lift? Well, that's just our distance resistance total. And this 24 feet would be our total distance effort. And so to figure this out, we just plug in what we know. We know the distance effort total is 24 feet, and we're trying to find what our distance resistance total is. And so if I just put 8 over 1, we can cross multiply and divide, and we're left with 1 times 24 divided by 8. Well, 24 divided by 8 is just 3 feet. And so if I pull 24 feet of rope through this compound machine, this weight will only lift up 3 feet.